All right, so we're going to finish this up today. We are on example 8. All right, so on example 8, we have a circle. Is this circle a unit circle?
No.
How do you know? The radius is 13. All right, so we're going to use this circle and point to find the sine of an angle that is twice as big as theta. So we're going to use the double angle formula for sine, which some of you know, some of you don't know. It's okay. We're going to jot it down. The sine of 2 theta is going to be equal to 2 sine of theta cosine of theta. We derived this already.
Yeah, I know we did, but I was like, the entire time I was writing it.
All right, to be able to use this identity, we are going to need to know what the sine of theta and the cosine of theta are, but we have the information we need to figure that out. So if we have a circle, it's not the unit circle, and we want to find the sine of an angle, what do we do? Aww.
Opposite over hypotenuse.
We're going to divide. This is x, this is y, and this is r. What are we going to divide?
The y.
And divide it by the r. Yep. So someone in my last class said the sine would just be 12 because she was thinking unit circle. But it's not, obviously, a unit circle. So you have to divide by the radius. Okay. What about the cosine of theta?
And that'll be 5.
So x divided by the r. All right, and then once we know those things, we can replace them or substitute them into the formula. So for sine of theta, that I know is 12/13, so I'm just going to make it 12/13. And then the cosine of theta, we just said, is 5/13, so I'm going to make it 5/13. And then for the sine of 2 theta, I would just multiply all those together. And if you struggle a little bit with fractions, you might want to put 2 over 1. That's up to you. So we're going to multiply across the numerator and across the denominator. And this is something that might be on a non-calculator test. So be smart with your multiplying. If you can multiply and get 10, that's probably better. So I could multiply that and get 10, and then multiply by 12. It's going to be 120 in the numerator. And then 1 times 13 times 13. Hopefully you guys know 13 squared is 169. All right, questions on that? All right, so that's one way that you use the double angle formula. All right, so on example 9, we're going to use all the new ones. Well, not all of them, maybe. We're going to use all the different types today of the new ones. Okay, so we have alpha and we have beta. And so we're going to do 3 different things. So I want you guys to take a second and find the sine and cosine of alpha and beta using the circle. For your sine, you're just going to take the y-coordinate and put it over the radius. And for the cosine, you're just going to put the x-coordinate over the radius for each of them. Right. and then for each part of 9, we're just going to use an identity and those values that we just found. And so for A, we want to find the cosine of 2 alpha. So we're just going to use this guy to do A, and then the other ones we'll have to use both. So let's look at the cosine double angle. We can use any of these. They're all going to give us the same answer. I think the first one in this situation might be a little easier because I know when I put those sines and cosines in that I'm going to get a common denominator that's going to be pretty easy for us to subtract. The other ones we'll have to find a common denominator. So I'm going to use the first one, but like I said, any of them will work out the same answer. All right, so I'm going to do cosine squared of alpha minus sine squared of alpha. So hold on, I labeled this wrong. So cosine of alpha is negative 5/6. So I'm going to put that in for cosine of alpha. And then sine of alpha is square root of 11 over 6. All right, so when you square a fraction, you're just going to square the numerator and square the denominator. And then this works out kind of nice. Like I said, you end up with a common denominator. So we can just subtract the numerators. Now, on our free response question, particularly number 4, they do want you to reduce, write everything in simplest form. So you would need to reduce this to 7/18. So what we just found is the cosine of an angle that is twice as big as alpha. All right, so on B, we're going to find the sine of an angle that would be if I took alpha and I added beta to it. So let's write down the identity. So it's one of the new ones from today. So this guy. And we're going to go back and just fill in those 4 values that we found at the beginning of this problem. Right. Now, what's kind of nice about this formula is when you do this multiplication, you should have a common denominator. So when I just take in front of the plus sign and I multiply those together, I'm going to get 2 square root of 11 and then multiply the denominators over 18. And then we're going to get negative 5 square root of 5 over 18. Now, more than likely on a multiple choice test, they wouldn't leave those separate. They would go ahead and bring them together as one fraction. And they definitely wouldn't do plus and negative. Right. And I'm fine with you all going straight from this red to the blue, which is what I'll probably do on the next one. Because I know I'm going to get a common denominator, so I would just go ahead and write it with one fraction. Now, someone in my last class was asking if I could reduce that 2 and that 18. What do y'all think? You can't. The only way you could is if all three of these numbers that are outside of the radical could be reduced by the same thing, and they're not. So we're done. Okay, let's look at the next one. So let's write down the formula for the cosine of two angles subtracted. So this is the one that's going to be cosine, cosine, sine, sine. And if the original is a minus, in between is going to be a plus. And then fill in the four values that we found at the top for each of these. And I'm going to go ahead and do one fraction because I know my common denominator is 18. And then this time, when I multiply those radicals, I can multiply 11 times 5 and get the square root of 55. So when you do an integer times a square root, you can't combine them. You just kind of like multiply them on the outside. But a square root times a square root, you can multiply. All right. You guys think I can reduce this? No, I know you want to, but you can't. There would have to be something in front of that square root that all three would reduce by. There's a 1 there. Nothing's going to reduce 1. Okay, what questions do you guys have on that? It's a lot. A lot of abstract analytical mathematics, which I know is not everybody's favorite, but it's fun. All right, so on the last, actually, the last one, this one, and the very last one, we're going to use the formulas in reverse. So it's like the identity has already been applied, and we're going to go back and figure out what the original problem was. And so on 10, we have 2 times sine of pi over 14 times cosine of pi over 14. So we're going to look at our identities in reverse. So what does that look like? 2 times sine of an angle times cosine of the same angle. Yeah, it looks like this. What should theta be? Theta is pi over 14. So what we're going to do is we're going to take that pi over 14 and put it in for theta. So what this is the sine of 2 times pi over 14. Now that is not an answer choice. However, we can get rid of a few answer choices. Bless you. So now you have to decide is if I multiply 2 by pi over 14, am I going to get pi over 28 or am I going to get pi over 7? Pi over 7. You multiply, bless you. You multiply that 2 on the numerator. And that reduces to pi over 7. All right, and then example 11, we have k, that is 4 cosine of 2x, and we want to pick which one of these is an equivalent form. Now, the cosine of 2 times an angle is one of the more difficult ones to use because there's 3 options that it could have been. So looking at the choices you have here, which is really the only option they used? Could it have been this one? Looking at D, could it have been this one? No, because there's a plus, and D has a minus. Or D has a plus and the identity has a minus. So it wasn't this one. All right. And then looking at all the other choices, could it have been the middle one? Do any of them have a sign squared besides D? No. So it definitely was the last one that they used. So let's figure out which choice it's going to be. Okay. So 4 cosine of 2x is going to be equal to, if I use that identity, it would be 4 times 2 cosine squared of x minus 1. So which answer choice looks like it would be the answer if I distributed the 4? Let's see. All right. Does that make sense? Okay, so the last one, we're going to use an identity in reverse. So we have cosine of an angle times cosine of another angle minus sine, sine. So which one does that look like? Cosine, cosine minus sine, sine. The cosine of addition or subtraction? The cosine of addition. It looks like this one. What is alpha going to be in this situation? Pi over 8. What about beta? Pi over 16. So what I'm going to do is I'm going to take that pi over 8 and put it in for alpha. I'm going to take that pi over 16 and put it in for beta. All right, but the answer choices obviously is not going to be B or D. So we have to figure out when I add these, am I going to get pi over 16 or am I going to get 3 pi over 16? Logic might answer that for you, but if I needed to add these, I would need a common denominator. What is it going to be? 16. So what do I need to multiply by to get it? 2. So we'll do that in the numerator and the denominator. All right, so that obviously is going to give you the 3 pi over 16. So it's C again. C seems to be a favorite answer choice. All right, what questions do you guys have? You're doing great. Hang in there. You're doing great.